welcome back and thank you for joining me again. We are now ready to walk through example 3 on applications of polynomial functions. Let's begin by reading the problem together. A storage box is a rectangular prism with a volume of 1664 centimeter cube. Now the box is twice as long as it is wide, and the height is 5 centimeters greater than the width. So determine the dimensions of the box. So as we read the problem, notice something important. All 3 dimensions of the box, length, width, and height, are related to the width. The length is described in terms of the width, and the height is also described in terms of the width. So it only makes sense to let the width be W. And then we'll express the height and the length in terms of the width. So we're going to write a let statement first. Now, therefore, we're going to say that, remember, twice as long as it is wide. So that means that the length, L, is going to be equal to twice as long as wide, so twice as long to W. Now, the height on the other hand, H, would be 5 greater. So greater means that we're adding 5 to the width. And voila, we have the 3 dimensions all expressed in terms of one variable. And that is very important because we can only afford to have one variable in a polynomial equation if we want to solve the problem. So the volume is length times width times height. And it measures 1664 centimeter cube, which would be length of 2W multiplied by width of W multiplied by height 5 plus W. So we have to solve this equation for W. It's a polynomial equation. It is not in factored form because we have a number here. We don't have 0, which means that we have to start by expanding and simplifying the right side. So we have 2W squared. So I'm going slow here and showing all the steps. It feels more natural to me to write the variable term first. And it also feels more natural if I wrote the variables on the left and the numbers on the right. So, but in this case, we're going to take this number to the other side, leave 0 here. So we have 2W cubed plus 10W squared. Remember where they come from. And then 1664 is coming to the other side. And again, as we mentioned, always feels better to have the variables on one side, numbers on the other, just 0 on the other. So let's keep our tradition. So in this case, we're going to have to factor. And the smaller the coefficients, the easier it is to factor. And I notice all these coefficients are even numbers, so they're all divisible by 2. So I end up with W to the power of 3 here. And then plus 5W squared. And then minus. So here we go. We have 1664 divided by 2. So that's an 8, a 3, and a 2. 0 over 2 is 0. So again, we are in a similar situation as in question 1. We need to figure out the factors based on the constant term, which is very large, and it has so many factors. But remember that we do not need to probably go that far because this number in here has a specific value, so the volume is a specific value. But we're going to search for the first factors in here. And plus minus 1, plus minus 2. I'm guessing that plus minus 3 also works. So 832 divided by 3. No, it doesn't. 832 divided by 4. Plus minus 4 works as well. And then plus minus 8 maybe. And then 10 doesn't work. But I'm going to stop in here and check and see if I can find a factor here. Remember that once you find the first factor, then the path is a lot clearer and faster and easier to get to the destination. So in this case, you're going to find out that the value of the function at 8 would be equal to 8 power 3 plus 5 times 8 squared minus 832 equals 0. So that will make 8 a factor. So we're going to say that w minus 8 is a factor. So we're going to take that factor and use it to help us find the other factors. So we have our other possible solutions, and we have the values of, this is our equation right here. So w cubed has a coefficient of 1. W squared has a coefficient of 5. Now there is no w term, so we're going to give it a coefficient of 0 here. And then lastly, we have the constant term negative 832. And we're dividing this by 8. So bring 1 down, 1 times 8. 8 plus 5, 13. And then we get 13 times 8, which is equal to 104. 0 plus 104 is 104. 104 times 8 is positive 832. And as you can see, the remainder is indeed 0. So we have w minus 8, and then w squared plus 13w plus 104 equals 0. We will factor the trinomial. So both will start with a w. We need two numbers that will multiply to a positive 104 and add to a positive 13. Let's check and see what we can get in here. So I am going to use the quadratic formula. It's a little bit faster. So 13 squared minus 4 times 1 times 104. And it seems to me that we get a negative discriminant if we try to solve this. So remember that technically what we have to do is make w squared plus 13w plus 104 equal to 0. And when you try to solve this using the quadratic formula, then you'll see that the discriminant expression inside the root, 13 squared minus 4 times 1 times 104, will be a negative number. And to be more precise, is negative 251. And then minus 13 here over 2. So the square root of a negative doesn't exist. So we're going to say that no solutions are coming out of this factor. So w equals 8 is the only solution. And w equals 8, the units are given in centimeters, will help us find the length, which will be twice w. So that's 16 centimeters. And the height, which is 5 more than w, which is 5 plus 8, or 13 centimeters. So in this case, we're going to say that obviously w has to be positive. 2w also has to be positive, which still states that w needs to stay positive. And 5 plus w, is positive, which makes w greater than negative 5 in order to get the volume that we have. And actually 8 is indeed greater than 5. Or another way that you can check if the solution is valid is to substitute it into the equation and see if it fits in there. Now, normally we would check for the domain of the function or for restrictions when we get multiple solutions, and we want to check and see if any of them is an extraneous solution. But that doesn't mean that this, is risk-free as well, so we need to determine that as well. But it does seem that it is working in our case because 5 plus 8 is positive. So the most important fact that we need to actually consider here is that all these three dimensions are positive at w equals 8. So therefore, we're going to say that the box measures 5 centimeters. I'm going to write it down here. Sorry, 8 centimeters by 16 by 13. All right, and that's the end of it. Now, in the next question, it's a different type of question, still application of polynomial equations, but this deals with not a real life application question. It's an application of polynomials, that's for sure. So we have to determine the algebraically where the cubic polynomial function with the given zeros will pass through this point and have this value. We're going to start off with the zeros. So the zeros are at -3, at +1, and at +4. And it passes through the point 2 and -20. And we have to find where does this polynomial function have a value of 40. Okay, so in this case, we're going to start off by creating the factors. So we have x plus 3, x minus 1, and then x minus 4. These will be the factors based on the roots. So this helps us create the equation, which will be f of x equals, there will be some coefficient a we are unaware of, we have to figure it out, x plus 3, x minus 1, and then x minus 4. Now, in order to determine a, we are going to ask for help this point that is given to us. Now, in this case, we have x equal to +2. So wherever you see x, we can replace it by 2. And the y value is -20. So what we have in this case then is a, and then we go, I'm going to bring these numbers a little bit lower here. So 2 plus 3, 2 minus 1, and 2 minus 4. So -20 equals a, and we have 5 times -2 times +1 times -2. So we have -10a equals -20. And that tells us that the value of a must be +2. So divide both sides by -10. So once we have this, then we have the equation of this polynomial function. F of x equals 2, x plus 3, x minus 1, x minus 4. So you're probably familiar with these type of questions because we've done them when we solved equations or when we discussed factoring polynomial functions. But this problem is a little bit different than the ones that we have done before because there is an extension to these questions that we've done before. We are given the value of y now of 40, and we need to find out at what x value this happens. So this will this will represent the value of f of x. So we have 40 equals 2, and then x plus 3, x minus 1, and x minus 4. So we're trying to solve the equation for x. For this, we'll expand the right side. We have x squared plus 2x minus 3 times x minus 4. And since we are here, we can divide actually by 2 both sides just to simplify the equation a little bit more. So we have 20 equals, this will become a 1, and we'll expand x to the power of 3 minus 4x squared plus 2x squared minus 8x minus 3x plus 12. I think we're going to need a little bit more room here. We have x cubed minus 2x squared We have 8x and negative 3x, making together a negative 11x. And then 20 is going to come from the left side, negative, so minus 8 equals 0. So from here on, we need to determine the factors. And I always try to check the number 1, so 1 to the power of 3. So remember that 1 will always give x to any power equal to 1. So this becomes a matter of simplifying the coefficients. So 1 minus 2 minus 11 minus 8 is not going to work. So we can try, let's say, for example, number 2 here. I don't have a lot of hope with number 2 because that will be positive 8 minus 8, 0. And then negative 8 with a negative, it's not going to work out. So I'm going to give negative 2 a try. So we have negative 8. We have another negative 8 in here. Plus 22 and then minus 8. That's not going to work. We didn't try negative 1, but that would be plus 11 minus 8. So we have, oh, there you go. We shouldn't have missed negative 1, so that would be 0. So therefore, we're going to say that x plus 1 is a factor. Once you have the first factor, we're almost done. So we're going to have the coefficients 1, negative 2, negative 11, negative 8. Divide them by x plus 1. So negative 1, negative 3, positive 4, negative 11, minus 8. So negative 1, positive 1, negative 3 times. So that will be negative 11 plus 3 is going to be negative 8. And here we go, positive 8 and 0. So we have x plus 1, x squared minus 3x minus 8 equals 0. I don't think this is factorable, so I'm going to try quadratic formula here. So negative 3 plus or minus square root of negative 3 squared minus 4 times 1 times negative 8. And that will be divided by 2. So we have 3 plus minus. Now we have 9 plus 32. 9 plus 32, it's a 41. Oops, we don't need this bit longer square root over 2. So therefore, we're going to say that the value of the function will be 40 when x equals negative 1, when x equals 3 plus root 41 over 2, and when x equals 3 minus root of 41 over 2. And there you go, we got the solutions to this problem here. So I hope the instructions made sense, and I hope you enjoyed the lesson. Thank you for learning with me as always. Bye for now.